Good day, everyone. Well, once again, welcome to another session of Mathematics for the African Child. Today we are going to discuss on how to find the derivative of trigonometric functions. How to find the derivatives of trigonometric functions. Now, we are already conversant with how to find the derivative of a function, maybe y being equal to sine x. We said that the derivative, that's dy over dx, will be equal to cos x. That one is a previous knowledge. Now, if a function y is equal to cos x, we said that the dy over dx of this will be equal to minus sine x. Yes, we are conversant with this. The next aspect we want to go into is situations where you have y being equal to tan x. Now, how do we find the derivative of this? We will now proceed on that. First of all, we will need to know that from our trig identities that tan x is the same thing as sine x over cos x. So it now implies that the function y will be equal to, instead of tan x, we'll now substitute this sine x over cos x. So from here now, we can simply use the what? The quotient rule to find the derivative. So let's proceed. Now we are finding this. So I will now say, okay, let u be equal to sine x and v be equal to cos x. If I have this, what is the derivative? The derivative of the function u with respect to x will now be du over dx, which will be equal to cos x. Then the derivative of the function v with respect to x, that's dv over dx, will be equal to minus sine x. Now substituting it into the quotient rule formula, which states that dy over dx will be equal to v du over dx minus u dv over dx all over v squared. Now let's see the substitution, please. We end up having dy over dx will be equal to, now you have a parenthesis. What is our v? Our v is cos x into, now the du over dx. What is our du over dx? Is also cos x. Then you close this parenthesis. Now our, you now say minus. So please, let's clean this. U. What is our u? Our u is sine x into dv over dx will be minus sine x. Close it, all over v squared. That will now be cos x all squared. So if we have things like this, what we need to do is to simplify further. So in simplifying further now, I will end up having dy over dx will be equal to, now work out this times this will now give us cos x squared, then this will now give us plus sine x squared all over, then we have cos x squared. So if we have this, then very simple. We all know that there is a trig identity that states that sine x squared plus cos x squared is equal to 1. Then check out this. Since addition is commutative, look at this. That is exactly what we have. That implies that our dy over dx will be equal to 1 over cos x squared. Cos x squared. So in cases like that, but we know that this is the same thing as 1 over cos x times 1 over cos x. Now 1 over cos x is what? 1 over cos x is sec x. Is that? So let's substitute it. You now say but sec x is equal to 1 over cos x. When we substitute here, see what we have. When we substitute it, we'll end up having our dy over dx will be equal to sec x times sec x. Finally, we have our dy over dx will be equal to sec x squared. That's our derivative. Okay, suppose you are given that y being equal to, let's say, cosec x. Now we can easily, relate it by saying, but cosec x is same as 1 over sine x. Now with that, when you substitute it, that will give us y will be equal to 1 over sine x. Then in finding this, we now say find the derivative of the function y. We now say let u be equal to 1 and v be equal to sine x. So if we find the derivative of the function u with respect to x, that will now be du over dx will be equal to 0. Then finding the derivative of the function v with respect to x, that will now be dv over dx will be equal to cos x. So if we substitute this into the quotient rule, that is dy over dx being equal to v du over dx, minus u dv over dx all over v squared. V squared. Is that so? When we do that now, that implies that our dy over dx will be equal to, so we have, what is our v? Our v is sine x into our du over dx will be 0, like this. Close it, minus. Then u, our u is 1, into our dv over dx is cos x, like this, all over v squared. Our v is sine x, so let's write it sine x all squared. So we can simplify it further by saying dy over dx will be equal to, now this 0 multiplied by sine x will annihilate the whole term, so we end up having 0 minus cos x all over sine x squared. So if we look at it now, check out, that means that we have dy over dx being equal to minus cos x over sine x squared. Now we can still simplify this further. Look at it very well. This is the same thing as dy over dx is the same thing as minus cos x over sine x times 1 over sine x. 1 over sine x is the same thing as cosec x. Then cos x over sine x is cot x. So when we substitute that, look at this as easy as it should be. So you now say, but cot x is equal to sine x over, cot cos x over sine x, while cosec x is equal to 1 over sine x. Now when we substitute there, finally our dy over dx will be equal to minus cot x dot cosec x. This is our derivative. By implication, we're through with this, then we'll go into another aspect of it. Suppose we are given y being equal to cot x, and we are asked to what? To find the derivative of cot x. Now, what we now need to do is that we know that cot x is simple as 1 over tan x. But tan x, you don't say but, tan x is simple as sine x over cos x. When we substitute it here, it means that cot x will be equal to 1 over sine x over cos x. By implication, it means that cot x will be equal to cos x over sine x. So now we can substitute this value into this, then we'll end up having y being equal to cos x over sine x. Now this is what we need to find the derivative of. So what we now do is that we now say let u be equal to cos x and v be equal to sine x. Then if you find the derivative of u, the function u with respect to x, du over dx will be equal to minus sine x. Then the derivative of the function v with respect to x will be equal to cos x. Now let's substitute into the quotient rule formula. We now have dy over dx will be equal to v du over dx minus u dv over dx. All over v squared. That implies that we'll end up having dy over dx being equal to, now what is our v? Our v is sine x into du over dx is minus sine x. Then you close it, minus, open, and our u is what? Our u is cos x into dv over dx. What is our dv over dx? That's cos x all over v squared, all over sine x all squared. So if we have that, by the time we simplify this, we'll end up having something like this. We'll end up having our dy over dx being equal to, this will give us minus sine x squared. Then work out this, you have minus cos x squared all over sine x squared. Now if we have this now, we can easily factor out the negative 1 of the numerator. That will give us dy over dx will be equal to minus 1 into sine x squared plus cos x squared, like this, all over sine x squared. But sine x squared plus cos x squared has an identity. I will now say but sine x squared plus cos x squared is equal to 1. That's one of the identity of that. So when you substitute it, we end up having dy over dx will be equal to minus 1 times 1 all over sine x squared. Multiplying it, we'll end up having dy over dx will be equal to minus 1 over sine x squared. 1 over sine x is cosec x. By the time you substitute this, you end up having dy over dx is the same as minus cosec x squared. That's our derivative. We can have this as our derivative. Very interesting. Sec x. Okay. If we are asked to find the derivative of the function y being equal to sec x, what we now need to know is that sec x is equal to 1 over cos x. So we can easily substitute this value into the above equation. We'll end up having y being equal to 1 over cos x. Now we can apply chain rule. Sorry, we can apply quotient rule now. So we now say let u be equal to 1 and v be equal to cos x. The derivative of the function u with respect to x will be equal to 0. The derivative of the function v with respect to x will be equal to minus sine x. So if we are substituting this into our quotient rule, which states that dy over dx is equal to v du over dx minus u dv over dx all over v squared. V squared, is that? Now, what do we need to do? We will now have dy over dx is being equal to, now we have, what is our v? Our v is cos x into our du over dx is 0, then close minus, our u is now what? 1, then into our dv over dx is minus sine x all over v, that's cos x all squared. So this 0 will annihilate this. You end up having dy over dx will be equal to 0, then plus sine x all over cos x squared. We end up, that means we have dy over dx being equal to sine x over cos x squared. Now, this is our derivative, but we want to at least, make it a bit simpler, look very nice. We know that this is simple as dy over dx being equal to sine x over cos x times 1 over cos x. Okay? So now, sine over cos is tan. 1 over cos is sec. So, when we substitute that, we now say but sine x over cos x is equal to what? Tan x. Similarly, 1 over cos x is equal to sec x. Then when we now do that, let's substitute now. Finally, we'll end up having dy over dx will be equal to, so this will give us tan x dot sec x. This is our derivative. So, if you like this, my video, subscribe and tap the notification button. Thank you.